Hello. Thank you. So I'm going to talk a little bit about, if not cable protection, at least stabilization of cable protection systems and cable systems. So where it all started. So I'm going to talk a little bit about, I'm going to take you a little bit away from interconnectors and export cables and a little bit to start where this started. And it started around offshore wind parks. And it started with scour protection, or scouring it actually started with. And where that came from, it came from that we had scouring around the foundations. And this was caused by the horseshoe vortices around the foundations. And the scour protection complicated for the CPS. That's been discussed enough, I think, around the other presentations today. So I'm not going to go a lot into this right now. And I'm not going to talk a lot about the cable protections either. I think others have done this today. Come on. Yep. The scour protection is also used on lattice or jacket constructions here from Submarine. Here we actually, one of the things that basically was found that the scour protection is not just used in shallow water or for the operation space, and for example in suction buckets here on Submarine. It's actually also used to secure that the suction is working during the installation of the suction, to ensure that the suction doesn't leak when we actually need the vacuum to get the suction into the seabed. Here you see one of the suction. It has the same size as a XXL monopile, approximately 10 meter in diameter. Suction here goes 8 meters into the seabed on each of the 3 sides of the jackets. Back to, they've been mentioned a few times today, Aurora, offspin of University of Western Australia. And what was the problem, or what became the problem for cables in fixed offshore wind, was that what they believed, to the left-hand side there of these 2 nice pictures from Aurora here, what one believed was the big problem was the tidal currents. And if we only have had the tidal currents being the problem, we wouldn't have had the cable problems, because the tidal shift obviously only happens every 6 hours. But the big issue was that it's actually the waves that give us the problem. And the waves, obviously, when we have a relatively large storm, we have a wave period time, maybe with a wave period time of something between 12 and 25 seconds or something. If we have a real big bad storm, we may have up to close to 30 seconds wave period time. And that's, of course, a very different story than 6 hours tidal shift. And that is because, and it's because we have these cyclic shifts that is generating these horseshoe vortices around the foundations, and that is actually circling around the foundation. This is the big thing that has basically given the big problem with the cables in the offshore wind industry, and has basically given us the problem with the CPS systems that have given us the washing machine effect, that have killed a lot of CPS systems. And so it was not just the scouring that got worse, it was also the cables that got worse. And cables look quite bad when they've been in such conditions. You can see that here. And that is not transformer stations. This is actually cables and CPS systems here in a rather sorrow state. This is not after 32 or 36 years, unfortunately. This is after anything from 9 to 22, 23 months. And this is not what you would like to see your cable or cable protection system look like, certainly not after such a short time. So the industry solution to this was that what are we going to do about this? They found out this is about mobility on the seabed. So the industry solution was a good, I live in Norway, so we had a good Norwegian solution. Let's put 17 tons of rock on this, and then we solved the solution. Well, the solution is not really good because pinning things under 17 tons of rock is like the same good solution. I talked to a few of you. You take your iPhone, I believe some of you have iPhones. So if you take your iPhone cable and you put that on the 5 kilo stone next to your bed, and you then let that stay under that 5 kilo rock, and you use your iPhone charger for a year, maybe 2 years, I think that iPhone cable will break. And you can start to think yourself, where do you think your iPhone charger cable will actually break? I think there's a good chance that that will break where the cable actually is pinned under the stone. And that's exactly what's going to happen with your offshore cable. You actually will focus all the fatigue in that point where you pin it under the 17 tons of stone. I don't know how many of you are so lucky that you're married to a wife that works in a quarry in Norway that actually has these 50 to 300 kilo stones that you can walk around and actually play with and find out how difficult it is to move just one layer of these, not to speak about having a layer of a meter or close to a meter, which is the armor layer of a scour protection. So if you do that, you understand that if you put 17 tons of rock over a CPS system or a cable system in order to stabilize it, you actually pin it pretty much. So it's like you take a cable you have back home, you put it in a vise and you move one part of it. For example, you move the part that goes into a foundation. You move that in the water column and you have one part of it pinned under the scour protection. You basically should not be very surprised if one day it breaks where it actually is pinned into the scour protection. This is the industry solution that is being the golden standard by some of the biggest developers in this world. I'm born, and I'm pretty proud of being born in Denmark, but I'm not sure that this Danish smart solution is a very good solution. So I came up with another solution because I worked for Seaway Offshore Cables for 3 years trying to find a smart solution we could actually do. How can we fix this solution from a cable lay vessel? We worked for this for 3 years. We found out how can we actually do things? How can we actually fix the supply chain solution from a cable lay vessels? We found out that we needed what kind of forces. The directors in the company wasn't very happy with me when I did a survey and found out I used some of the resources we had in the company. I did some CFT surveys on 3 different projects we had, came up with the water particle velocities on 3 projects around the world we had, and came up with some pretty troubling numbers. The company found out we have two kinds of problems. We have a problem that these analysts, they give some very troubling numbers, but they found out we have 2 kinds of troubles here. We have trouble with these high velocity numbers, and then we have this trouble called Henrik. They found out that the best way to solve this problem was to get rid of Henrik. That's the reason why I'm here. That's the reason why I then found out, okay, unfortunately, if I, what happens? Oh, there it comes. So sometimes if the mountain can't come to Mohammed have to come to the mountain. So basically, I had to then find out, can I find a way of doing this? We tried to speak to. We found out with the forces that we saw, the ULS forces that actually kicks to the CPS, the cable system. They kick on a semi-protected system. Semi-protected systems means, for example, in the North Sea, protected by UK. So we only have, for example, a project that's partly protected by UK. So you only have waves with a height of 10 meters in a very severe storm. Then the ULS kicks in with something like almost 15 tons to the CPS systems as a seabed, or a project, for example, let's name the project, Holland's the Coast Suit. 15 tons we get on the CPS system. So if we wanted that CPS system to stay put, we needed a weight. I asked Norwegian Geotechnical Institute, we need seven tons of weight in water to keep that relatively stable. 10 tons if we want it fully stabilized. Can we handle that from a cable lay vessel? We found out, no way, we cannot handle that in a lay trajectory from a cable lay vessel. The project was dead. So both that I found out the water particle speeds or velocities, and that we couldn't handle it from a cable lay vessel, my project in seaway offshore cables was dead. So that's a full story about why I'm here today. So the Portsmouth Solutions, I found a way that I could actually do this. I found out I had freedom to operate. I started up, made a patent, and made a company called Portsmouth Solutions, that we could actually find a way that we could install, stabilize the cable, and pull in from a cable lay vessel. We could not bring the weight of 7 tons or 10 tons from the surface. So instead, we were going to use the stability of the seabed, not bring it down to the seabed. So we're going to use something called a screw pile. So instead of bringing the weight down to the seabed, we're going to use the seabed. So we're bringing down a screw pile that weighs less than 200 kilos that will give us the stability of 33 tons. So that was a smart thing that we were going to do about it. We're then going to do alternatively from the cable trenching vehicle, we were going to do that from an ROV. We were going to install it from an ROV, and we were going to do it on top of the scour protection. Microphone. Sorry, I'm losing myself here. Sorry for that. We were going to do that without putting any rocks on top of the cable, no impact to the cable. And we were going to have no post-installation campaign, of course. So early, it was going to look like this next to a monopile. We were going to stabilize it while we actually put the screw pile into the seabed. We get a verified anchoring strength. This we get from a study that's made from Aalborg University, where they've made 30,000 tests where they actually screw in the screw piles in the seabed. And while they do that, they actually get the verified anchoring strength. So we can stabilize in seabed without knowing actually exactly how the seabed is, because the seabed is going to change between our clients. They actually do the CPT surveys and something. They actually build the wind park, or they trench the route. They change from virgin seabed to actually come and stabilize. We don't know exactly what the seabed is like, but we don't really care, because we actually verify the stability or the anchoring strength when we actually screw the screw piles into the seabed. We then have a bend stiffener on the thing, so we can control the curvature of the cable when it goes in. So we don't care about what the seabed looks like when we got our screw piles in there. We got a bend stiffener on it. We can control the The free span, I can show that a bit better here. I'm a bit behind time here, so I think I'm gonna take that next.
If you can point at the back, I think that would.
Okay, here we see it.
There.
Yeah. So in terms of controlling the free span, you can see on the right-hand side here, you can see that when we close us in the system there, we actually have kind of I call it an artificial floor. So we actually close us in a floor within the PSS. So we can actually, we hold the cable system or the CPS system in there. So we can then allow the seabed to drop. So we can then hold, we can allow the free span. So we can interface with a seabed that drops. We can interface, for example, the HDD bellmouth. So if there's a changing sill, changing seabed and something, we can allow that. We don't have to do things, but it will work fine. For example, if there's a small distance, we can work with a few sandbags, filter units of our friend here. And in floating with dynamic cables, we can get rid of all the stuff down at the seabed. We can just have this, and we can work with very low, for a floating object, we can work in very low water depths. So we can work with a lazy system without having any lazy part of the cable. Sorry. This way we can actually facilitate floating systems in less than 100 meters of water and ensure that we don't have any collapsing between the dynamic cable and the mooring lines. We just need, the only thing that we need to install on the back deck of the vessel is the cable clamps, and no heavy lifting, no anchoring, no dead weights on the dynamic cable. Same for canyons and depressions. You can load out the cable just with the cable clamps, and we can install the PSS on the touchdown on the seabed on either side of the canyons, and we can install the PSS, and we can install sealed PSSs on both sides of the canyons. We actually have done all the penetrations on where we penetrated the systems through armor, rocks, and scar protection. This is all demonstrated. You can find this on LinkedIn and on our webpage. And we'll do our wet test Friday this week, and we're about to commercialize our system at the end of this year. So this is where we are now. So that's what I wanted to say.
Thank you. Vinny already has a question. Everybody else, he can also think about one. It's because he wants to leave out rocks. It's yeah.
Oh, Renee, she's gonna say something.
Thanks a lot, Henrik. I have a small in cables background, but I have also a very long history in rock installation. We don't call it rock dumping anymore, but it's rock installation.
We don't have time for that.
And one of the things is that during my whole lifetime with installing rocks on crossings, on cables, on pipelines, etc. In general, we didn't need any protection on top of a cable or a pipeline when we dump rocks on it. However, on cables, sometimes you have the protection systems around it. And that's the reason why they're called cable protection systems. They should not only protect against the waves and other things, but they should protect against the rock as well. And you're overcoming this. How can you explain that? A cable protection system should do what it's called, cable protection system, also protecting against rocks. So what's wrong with scour protection afterwards, or fitting the cables by scour?
René, it's a very good question. And if you asked me this up to 2019, I would have answered this question. Now I sold my CPS company in 2019. Now I can no longer answer this question.
Perfect. Okay. So we'll have to read between the lines. We have a question in the back of the room. And then no, there.
Yes. Hi, Wouter Vermeers from Jan de Nul. How do you screw these pins into the ground?
Well, into the seabed. Well, are you talking about the scour protection or are you talking about the seabed?
No, your pins. How do you pin your?
Yeah, the pins, how the screw piles, as we call them.
Yes.
Yeah, how do we screw them in? Do you want to know how we screw them into the scar protection or into a generic?
Scar
because-
protection, native soils,
Yeah.
whatever.
So the screw piles is screwed in with an RV. Is that what you want to know, or do you want to know more specifically how the screw pile is?
I just want to know how much time it will take because
Yeah,
time is cost
okay.
and okay.
Yes.
You mentioned it can be done from the CLV or the TSV, but how long will it take? Which equipment you need?
Yeah.
And especially to go through armor, I think is pretty challenging.
Yeah, it's very challenging to go through the armor. So the armor takes an armor layer where you have 50 to 300 kilo armor layers, or from one of the new layers, for example, that you have used in your new US projects. That was the same grading that we were using from the same quarry in Norway. So we use the same gradings from the very same. So we use from the same from the same quarry in Norway. That takes 90 seconds to get through the the actual scar protection. So it's quite fast to get through, but it takes about 5 minutes to screw from the entire piling from one pile. So it takes about 12 to 14 minutes to get the two piles installed.
Okay, can we find movies on your
Yes, you
website?
can
Or?
find if you go to LinkedIn at the moment. We will upload the video on our webpage also, but you will see it on LinkedIn. You can see there's and that was uploaded at the start of October on LinkedIn. So if you go for my name or the company name, you will see it on LinkedIn. Yes.
Thank you.
Perfect. Yep. Michael already has a microphone.
Okay.
Can you hear me, Henry?
He
Yes.
can. He's just trying
I
to run
can.
away.
I can hear you, Michael.
You're not getting away just like that. Just a quick comment and question. As all things on the seabed, when you put a foreign body on it, whether it be the turbine tower or whether it be a cable, you will get a certain amount of movement. Presumably, this system that you are putting forward will be subject to monitoring. So in other words, it can be adjusted after a while when the cable settles down and your system settles down. It's not something you just put down and forget about it. It's something you would need to monitor.
To monitor it.
Monitor. Keep an eye on it.
Yes, but most developers don't want to monitor. So yes, of course you can monitor it, but that I was hoping that the people that have presented before could do it via the fiber, because I'm a great believer in that if you could do it from a control room dry, but of course there are people that have remote sensing. You could do it from a flyby or something like this, but that requires, of course, different thing. But it really would be in the ideal world, it would be that they could sit in a control room and they could use the fiber and basically see what's going on. So I was hoping that one of the fiber optic people could actually come in and say, yes, this is moving so and so much, and the bending is only so and so much. But I'm not sure if I'm asking and hoping too much.
But the question I think is, do you need to monitor, or can you put it in and forget about it?
The idea is with most of the mechanics in bend stiffening and so learning from offshore oil and gas in bend stiffness, and so none of those are instrumented.
Okay,
But
we have one more question. No? Who? Ah, you. Okay.
Yeah, thank you very much. Nice presentation, Henrik. And this is Buket Yenigül from Seaway 7. I have a question. What is the dimension of this pin screws? And what's the difference between when you do it in scour, what will be your penetration depth, and the seabed? And if it's in the seabed, if you have very highly mobile seabeds, how you are going to solve the problem then? Thank you.
so the dimensions of the screw piles are can be the same. So in the North Sea, where we have a relatively stable seabed and not very mobile seabed, the typical screw pile is a screw pile of 3.6 meter length, with the diameter of the actual helix, it's a continuous helix that we use there, is only 120 millimeters diameter. If we go, for example, to one of the projects that you will know well, which could be either CFXD or Songning. Songning, for those that don't know it, is a project that was predicted with a scour depth of maximum 3 meter, extend 12 meters. The actual result was depth 12 meters, extend 107 meters. So a difficult field with very mobile seabed. In such a project, we would use the same 120 millimeter diameter thread, but most likely the length of the screw, because we have threads in each end of the screw, would end up in either 18 or 24 meters. Yeah. So we would keep extending the screw till we actually get 33 tons of anchoring strength in the screw. So we would keep screwing the screw, and then to the gentleman from DEMA, we would then not be able to do that in 14 minutes. If we had to screw down the screw in 24 meters, then possibly it would take twice as long to get 2 screws down to, for example, 24 meter depth. It will still be 24 meters because the RV will be able to do the exchange of both. It can screw both sides, and it can also revolver change the length, because each screw is not 24 meter long. Each screw has a standardized length. So the length of the screws can be up to 6 meter long individually, but they can only be a certain length, and then they are interchangeable with female, male in each end. Yeah.
Perfect. But then, thank you very much for your
I'm not
presentation.
getting any of the.
Well, that's a question. That's a question. So that
Sure.